welcome again to everybody on the line. Thank you to the teachers, to Michael, to the students for doing such an amazing job. And I'm very excited to show the work that people are doing through this BioBuilder Accelerator. The curriculum that we offer through this open access platform has materials that are oriented towards students who are interested in integrating biology and engineering, as well as support materials for teachers who would like to bring this into their classrooms, their after school efforts, and for their own skill building and advancement with it.
Tretinoin is one of these drugs. We will use synthetic biology to produce a better acne treatment.
In our research, we concluded that the system we designed should end up reducing the dryness of skin for people who use this medicine. Therefore, we came up with that our inputs are a cell that can detect dry and flaky skin caused by Accutane, medicines, and eczema. The natural occurring bacteria called Rosamonas mucosa will be genetically modified to produce tretinoin when applied to the skin, meaning it will be temperature activated.
Our team has chosen to replace urban streetlights with genetically engineering glowing street trees.
We will use firefly luciferase because it is already used in many biology labs and emits a natural and soothing light.
Glowing plants can be beneficial environmentally, aesthetically, and emotionally. Looking deeper into this subject, we could venture into the idea of light inside our homes with plants that are easy to care for, such as Monstera deloisa. Hopefully soon, the world will be filled with this soothing natural light and reduce the need for artificial
structure. Our input would be a promoter that detects a CA9 protein. We chose to detect this marker because it's commonly found in lung cancer cells. The bacteria we use would bind to these CA9 proteins on the outside of those lung cancer cells. Our output would be a clumping or clotting mechanism. The bacteria would use an autoagglutination to connect to all the other bacteria cells that are connected to CA9 proteins. The next step in our design would be to figure out a type of bacteria cell that already uses autoagglutination as a mechanism.
Hello everyone, I'm Nico, and I'm going to be talking about the system design of our project. The system we designed should give people an easier and more tasty way to help them fall asleep. Instead of taking a pill or two, you would just need to eat a few grapes and the job will be done.
The system we designed should use 2 different strains of the E. coli bacteria to create an alternative fuel. The input will be the ability for the E. coli to use carbon dioxide as its food source. The output will be the oil that is produced by the bacteria, which, according to our research, is similar to diesel fuel.
Essentially, the mixture of the two would create a new strain that both takes in the CO2 and produces the diesel fuel as a result, creating a net zero effect in the environment with CO2 emissions.
80% of marine debris originates from city litter. The system we designed should utilize the large pigeon population and pigeon waste in cities to biodegrade surrounding plastic waste. For the pigeon waste to break itself down while also breaking down plastics, a common gut microbe of birds known as Bacteroidetes would be edited to include properties of the Bacillus microbe, but only when waste is excreted. In other words, when the system detects an increase in oxygen or decrease in temperature due to exiting the bird, this microbe can enhance the degradation process of both the waste and the surrounding trash. The next step